is driving down the road and it slams on the brakes, it's going to eventually come to a stop, and we want to know how far it's going to slide before it actually comes to that stop. When you slam on the brakes, there's a force of friction from the tires in the road that's trying to make it stop. The normal force goes up, force of gravity goes down. I wrote all the numbers that were given in our problem. The frictional force is 8,000 newtons. The mass of the car is 650 kilograms. And we know the initial speed, and we know this car is going to stop, so its final speed is 0. What we're really trying to find is a kinematics value of the distance the car slides. But we don't have enough numbers to just go right to kinematics. We need 3 numbers in order to solve kinematics problems, and we only have 2. So we're going to find our third number by finding acceleration in Newton's second law, which is all the forces add up to equal ma. Now, up and down, we know the car is not accelerating. Our normal force up and our gravity down would be equal to each other because there's no acceleration up and down. So we look to the left and right for where our acceleration would be, and that would be the force of friction slowing the car down. There's no force pushing the car to the right. So we're out of forces, and that's going to equal the mass multiplied by the acceleration of the car. Now we're trying to find that acceleration. The algebra is easy enough. We just divide the mass over to the left side, and that will give us the acceleration. And now we can plug in our numbers. We know the friction is 8,000, and the mass is 650. Plug that into my calculator, and I should get the acceleration is 12.3 meters per second squared. Now we're almost finished. We have to also take a look and say, well, is our acceleration in our positive right direction or our negative left direction? The answer is it's in our negative left direction. So we need to make sure that we realize our acceleration is a negative thing. Now we know initial velocity, final velocity. We're looking for distance, and we have acceleration. So we want to pick our kinematics equation that does not have time in it. And that is the Vf squared equals V naught squared plus 2AD equation. And we're going to rearrange that for the distance, because that's what we want. And algebraically, it would look like this. Vf squared minus V naught squared all over 2A equals our distance. And we can just plug in our numbers. Vf is 0, so I'm just not going to write 0 squared. I'll negate that. And we'll just have the negative V naught squared, which was 25, squared all over 2 times negative 12.3. And we plug that into our calculator. We find out that the car drives 25.4 meters before it comes to a stop.